Hey guys, how's everyone doing? Um, I'm gonna wait a bit before to give people a better chance to join, but I want to go over some of the stuff that I did with the schematic. I changed it a little bit, but like I said, I'll give people a minute to join. How's it going, Intermit Tech? Ahid, how's it going? Johnny, how's it going? Oh, blue screen of death, outstanding. That's just the power that these streams have, apparently. Hey, Bradley. Okay. Um, so essentially, in the last, where we kind of left off last time, hey, T Electronics, where we left off last time was essentially kind of seeing how the simulation had them putting like I think it was like 10 or 15 output ceramics all in series or all in parallel. It showed it based on the VSEN plus and minus pin, but since obviously they're connected to the output of the inductor, they're essentially the same thing as the main node here. And then just a touch on the input side. But one thing I just realized I didn't have, hey, Groza, I did not have the inductor chosen, or I have it chosen. I just didn't put it on the schematic. I made all of the footprints for the board. Okay. Um, I'll pull up. I don't have it up right now. The simulation for the regulator, just so we can reference back to that, because their simulator is quite wonky from what it appears. Also, what do you guys think of the green screen, making it so my it's not a box around me? It looks terrible. That's because I don't have proper lighting, but soon enough that will change. I figure it just kind of makes it less obnoxious in the background. So VN nominal is 12 volt, VN minimum, I guess 4 volts, 5 volts. V out is 5 volts. Oh, they want it to be 6 volts. Switching frequency is a megahertz. Output. Okay, now it's 7. Okay, so hey JF, how are you doing? So something that I did not realize, they spec for by default an inductor ripple of 30%, which at 15 amps is what, 4, 5, 6 amps, which is a crap ton of ripple. But it's really funny because even with a value that high, they still were going with a 1 microhenry inductor. So like if we are to change it to 10, it'll change, but it still doesn't change the obnoxious amount of output ceramics, which is really weird. Apart from lighting, it looks spiffy. Appreciate it. Oh, I'm looking fine with or without. I appreciate it. That's always the goal. And there's simulation. Oh, that time it didn't take too long. Okay, so that made the inductor larger on the output side, which you would expect. But it still has 6 output ceramic caps at 3 milliohms ESR. So what I did, and I mentioned I was going to do this on the last video, I put together a based on AppNode 1197 and then SLTA55. I've mentioned them in quite a few streams. I finally put together like a script to do all the calculations. I should have done this a long time ago because I literally would by hand do all of these each time, which is kind of funny that I never did it. Add a green shirt for the floating head. Yeah, right. I was thinking, do I have anything green? My Lulz bot, I think they call it like the Roctopus, but I guess that's not quite the same color enough. I don't know what else I have. But essentially this takes all of the calculations and everything and spits them out to what's like the minimum inductance, peak inductor current, all that. What I'm going to do is I'm going to start putting a bunch of tools and stuff on our website. So it'll be like just like the calculations for unit conversions. And I think that could be pretty useful. But I don't know. I don't know what the simulation is doing. I don't understand why they would have 6 10 microfarad output caps. It doesn't say anything about that in the data sheet, why it needs to have like essentially no ripple out here. Because if we base, so for the main calculations for calculating the inductor ripple is essentially what is your output ESR. So what is your ESR of the capacitors going from your output node to ground. And the size of this doesn't really matter because it's just filtering on your low pass filter on your LC. And then you can set what you want the voltage ripple to be, and then it's just Ohm's law. So even if we set our voltage ripple to 8 millivolts, which is minuscule, and 2 milliohms, which is pretty easy to do with just a few paralleled resistors, I'm getting an inductance of 0.73 microhenry, which makes the 1 microhenry inductor totally fine. So I don't know. I wish they would show some more of what actual simulation this is based on, because it doesn't really seem accurate to me, and why there would be 6 JF parallel caps, lower ESR, any specs on output ESR. You jumped the gun. I was getting to that. Hey CFXS, you haven't missed a whole lot. Just talking about, I don't think this simulation's very accurate. So JF makes a fantastic point. So on every voltage regulator, every buck regulator you'll use, the way that they compare to regulate the output voltage is they measure on the ripple, and that's how they determine if the voltage needs to be increased or if the duty cycle needs to be increased or decreased to raise or lower the voltage. And this regulator explicitly says, thanks to the internal current ramp information, no high ESR output bulk or virtual ESR network is required for loop stability. Since they're not using the standard voltage divider with 2 resistors here and sensing it, they are essentially saying it can have as low of an output ESR as possible. There's no limit, which, like I said, I've never seen a regulator that does it like that. because essentially with these three caps, their ESR I think is 434 milliohm, something like that. So adding in parallel, I mean they're really really small. So I don't really know. Normally this would not work. This would not regulate. There would be very, very little output ripple, and you would have to have what's called like an injection, a ripple injection circuit, where you add an RC in between your switching node and your sense. But they are saying that they don't care about it, so it's an evaluation board. I guess we'll test it, but that is definitely new to me. But I have also never seen a sense configuration on the output side like this, so I guess I can buy it. Um, so that's that. The other thing, I guess the sim is made for some generic ICs. Yeah, like I said, unless someone else can find it, I mean, it's Power CAD simulation tool. I don't exactly know. And I actually registered and saw like the simulation results, and it's like super, super generic. Oh, Transim. I just noticed that. What is Transim? Cloud-based engineering. So it's a custom thing. Engage. So they simulation tools. I mean, electro simulation, buck boost, transient. So it's a custom thing by them. Interesting. Yeah, but I'm assuming that they just take something generic because there's no reason you would need 60 mics of ceramic on the output side. And then I don't know why they separate it from here when they're connected to the same node, unless that's to show that they want it close to the positive voltage sense. Again, I could be wrong on some of this. I've never used this IC, but I guess we'll see. So, the other thing that those two data sheets or the two app notes, you get obviously your inductor current, you get your RMS inductor current, your peak input current. The peak input current is most useful for obviously sizing your input regulator size and also sizing your filter, for this one a ferrite, or your filter inductor. It also gives us the energy for the inductor. That's a little extra. You normally don't need that. So would you normally put some empty pads for extra caps in case? Yeah, I mean, certainly could. Probably wouldn't hurt. The other thing that you can also do, and maybe this is something that you guys can decide. So depending on what the actual output, the transient load on here is, in this, I've never just kind of blindly made an evaluation board like this. So if whatever you're powering out here has like really big transients to where steady state is say like 5 amps and then it ramps up to 10 or 15 amps quickly, that can absolutely sag this entire rail down, and then you're going to be forced to grab it all on the input side. That's when you would want some bulk capacitors. But if it's just kind of a steady state load with an half an amp, 2 amp transients, it should be fine. But more so than adding more 22 mic, just because I think they're wrong. I don't see under what planet they would require 6 of these unless the data sheet is misleading us and it has to be low ESR, um, which they explicitly also say in the description. Someone pointed it out last time. Well, it essentially says it can be used with any output capacitor. So I don't think that extra pads of this would be useful. I think what would be more useful potentially is having some bulk capacitors, but I don't know. Maybe you guys let me know. I mean, I don't know how like broad this needs to cover, what scenarios. Um, so then the next important spec is the minimum ceramic input capacitance. And essentially what that is for is on the input side, we put a spec for what the input peak to peak voltage is. So that is essentially on this node here, what is the maximum that we want the voltage to peak up and down with? This is almost exclusively for EMI or EMC issues. The lower your peak to peak, the less noise that can be coupled back onto your input cable and radiate, or coupled to anything else on the board and get differential to common mode conversion. So the lower you can have that, the better. Normally, a rule of thumb is 100 millivolts. If you have a pi filter with an actual inductor, you can get away with a higher peak to peak, but since we just have a ferrite, 100's probably fine. So we get 37 microfarads, and since I have one 0603 here, that's not right. That should be 0603. I know that because I literally finished changing these like 2 minutes before the oh no, that was sorry, it is 1206. I was thinking 1210. I finished this like the second that the stream was about to start. So this is a 1206, little better for high frequency noise rather than the 1210, and they're close enough in value, or at least this is a high enough value where we shouldn't get that anti-resonance peak with different valued caps in parallel like I've mentioned before. So these are, if they have an effective capacitance at 20 volts, because that's the highest that this is rated for, and I used SimSurfer for this. Did I drag it over? No. There you go. Okay, so I use SimSurfer for this, and essentially the effective capacitance at 20 volts was like 5 microfarad. So I have 6 here, and then we've got some ceramic caps here, and that helps with pretty much exclusively the peak-to-peak ripple. Then we also have a couple bulk capacitors here. And what these do is, so on the SLT055, they do not have a diagram. Fantastic. Okay, so from this point on, since these are all going to be super close to the regulator, everything upstream from here and back to the wall's power supply has a decent bit of inductance. So if there's a big transient on the output side, or it just ramps up to a high current, these ceramic caps are going to get depleted fairly quickly. And if you don't have any bulk capacitors here, the only place that they can draw current from is from your wall supply. And since you have an inductor on that wire, it most likely isn't going to be able to do that. So your 12 volt supply or your 12 volt rail quickly becomes 11, 10, 9 volts, and bad stuff happens, a lot of noise. You can get brownouts and all sorts of bad stuff. So they have an equation on there, which gives you what your minimum bulk input capacitance is, and it's based on what that is not microamp, that is nanohenry. That is the input inductance on this side. Since we don't have a true inductor here, 560 is just kind of a rule of thumb, and you always want to have more bulk capacitance than they say, because that's essentially like worst case scenario. And then the other assumption that is making is, and this is back to what Ahid was saying, is on the output side, we have, where is it? Output transient current. So I put a transient current of 5 amps. So that's saying if this is drawing 5 amps, then worst case, it could ramp up to 10 amps. And that would be a transient spike. or it could be drawing essentially 0 amps and then ramp up to 5. It could be at 10, ramp up to 15, and so on and so forth. So if we were to put this at 15, obviously our input cap requirement is going to be a lot bigger because there's going to be a lot more there's a lot more current. So when these get depleted, we need more bulk capacitance to fill these up. And then the other thing that makes a massive difference, even more so than the output transient current, is if we were to use a bigger inductor. So say if we were using like a 4700 nanohenry, so a 4.7 microhenry, are, I guess they're about equal sides. So if we had a bigger series inductor, whoops, don't know what that was. Oh, it's part of my chair. Lovely. So if we had a larger inductor for a pi filter, that is going to also require us to have more bulk capacitance. But with this, we should be good. And then the last thing that I wanted to mention before we get into the other stuff and the layout is our ferrite. So the ferrite that I chose isn't the one that I had talked about on the last stream because that wasn't rated for high enough current if it was at 12 volts. So here's the chart of what we're using. So anything up to 100 megahertz, it's more so just going to be an inductor until the crossover point. But what's really, really, really important that I didn't mention with ferrites is this one actually is pretty fantastic and it's not even that big of an issue. But similar to ceramic capacitors, they have a nasty DC bias. So the more current that is going through them, the less effective they are. So you can see with this chart, the difference between 1 amp and 5 amps. It's really not noticeable at all. It really won't make a difference for us. At least they conveniently say that the max that their test configuration can do is 5 amps. Hopefully that means it just is linear down here and it doesn't like drastically reduce. But that's another reason why, like in the last stream, I essentially said if you can, if you have the ability cost wise, board space wise, and bulk capacitance wise to have a inductor and do a true pi filter here, it's almost always going to be better. It's just you require more bulk capacitance for the reasons I just said. And inductors don't have that DC bias issue. So as long as you don't saturate them, you're good to go. You don't have to worry about any issues with them starting to bog down. Hey, Patrick, how's it going? So I have all of the footprints and everything ready to go for the layout. Does anyone, before I jump into that and get out of the schematic, does anyone have any other either questions or thoughts that we didn't change or discuss on the last stream? Let me know. If not, I'll go ahead and jump into the layout. And for this, these are just 2.54 millimeter pin headers. Jumper is the same thing. This jumper, same thing. And for the input and output power, I have them just as a placeholder as 2.5 millimeters. Those obviously aren't going to be big enough to handle 15 amps and whatever, 5 to 10 amps. So I will sometimes just use that because you can always change it at the end. So also, if anyone has any suggestions on connectors for those, let me know. But if not, I guess I can go and jump into the layout. I'll give you guys a couple other minute or another minute or so to let me know if you have any other questions. Oh, I spilt water on myself. Lovely. And then I guess the only other footprints, these I just added 1.5 millimeter square test pads here. It is fine. Did you ever notice Ferrite on schematic for digital power of microcontroller? Yes. So that's something really, really, really good question. So that's something that I am absolutely going to be doing in an EMC video. It's something that a lot of data sheets and hardware notes will suggest, especially I believe Atmel, which now Microchip for all the Atmega series, they were really, really bad at always suggesting it. So what Patrick is essentially saying is, let's say this was a microcontroller and this was the input supply. They would recommend having a ferrite on the input to it. And full disclosure, I used to do that until I forget who I had first read it from. Maybe Henry Ott in one of his books. And then Grounds for Grounding and a couple other books and lectures I had seen mentioned it. So it's really a terrible idea. Like you can get away with it, but for a high-speed microcontroller, it's about the single worst thing you can do. It seems like a good idea because the theory is, oh, any of your digital switching noise can't get back onto your main power supply, but that also means any of the high speed switching, it can't grab power from either. It essentially blocks it off. So what people will do, and this is what Atmel and them will say, is, oh, just put a bunch of capacitors. That's how you get the high speed switching. That used to work maybe 10, 15 years ago with slower ICs. You can't do it now because anything over 500 megahertz, capacitors, even ceramics are useless. All of that comes from interplanar capacitance between the planes, which if you do this, you completely remove all of the planes. So yes, if you were to add a big plane on this side of the ferrite with ground, that would work, but you're much better off using your ferrite on the other areas to separate the analog side, which is slower, or to keep it off from leaving the board. But like I said, I'm going to test that in an EMC video. Can you show how we define net classes for defining tracks and widths? Oh, you're not going to like the way I do it. I don't do it the proper way. I do them mostly on the fly. I should get better at it. But yeah, certainly when we get into the schematic or into the layout. A tickable choice for other modules, one of those screw connectors, and then pads on the side for soldering cables. I get the screw connectors. What do you mean by the pads? You mean so you can solder wires directly to the board and then also be able to use screw terminals? Yeah, that makes sense. But just let me know if any other questions with the schematic. We can always jump back. And I'm gonna have the schematic on the on my other screen for now. And I didn't see Daniel in the chat, but he was complaining about my messy desktop, so I put in a nice new folder, so now it's a spotless desktop. Okay, and then I guess does anyone have any thoughts on how this actually gets laid out? Like where input power is, output power, anything like that? I guess the only real question is the input side presumably is on one side. Do we then have the connector for the SDA, SCL, power good, all that on that side? Or would we rather have it somewhere else and then our output power is on this side? Anyone have any other thoughts? I think that makes sense, at least to me. So then for board setup, they changed it around a bunch on the nightly. Oh, looks like Jello. I remember KiCad does that sometimes. It's kind of weird. I don't know how well you can see it. So track width. Yes, you can either use pad, solder cables. Not sure if it's a great idea or not. Okay, yeah, we can do that. I don't know if that'll probably be something we change at the end, but yeah, that makes sense. Um, Minimum track width, I will start with 6 mils. Via diameter, I try to do 25 mils. Hole to hole clearance, I'll keep that where it is. And then for vias, my standard via will be 25 mil hole with a, let's start with 30 mil hole and then I don't know, we can try 50 here and see how that is, because they typically will upcharge you if it's 25 mil hole, but we can see. And then here, clearance 6, 6. Via will do the same thing. So 25 and 50. Cut out under coil or do not. I don't know, man. That's one of those things that everyone seems to have a different theory with. I don't. I don't think I honestly have ever done it. But yeah, I totally agree. People say they do. I don't know why. Um okay. Oh, I'm still switching over everything to metric. The via hole, that's this is supposed to be in millimeters. That would have been a massive via. And I believe, Yusuf, I believe what you were saying is adjusting nets for these. That I never do. I always just change them on the fly. I find it to be a little bit faster. But either way works. So like when I'm routing a trace, I'll just adjust it here rather than doing it any other time. But either or. And actually, what I'll do, since I'm not even using any 0402s, we can make the default track width 0.2. And then clearance. Let's see how that goes. Is two-sided PCB a must, or can you get away with single-sided? Oh man, I would say 80% of what we do is single-sided. Double-sided are just a pain. One good thing about when we're doing assembly of boards is we have the ability, we've done the design. So as long as you have heavy parts on one side and light parts on the other side, it's pretty much a piece of cake, but it's still two processes, so it's always going to be more expensive. So if you can get away with it, you always want to have single-sided. For something like this, absolutely makes no sense to have double-sided. And then, like I say on every single layout, when I first do the layout, I don't care at all about trace widths or doing any pores or doing things pretty, because I know I am not good enough to be able to do this in one go. So I'm gonna have to go back and like redo all of the traces. So to save time, I don't even try to do it properly the first time or pretty the first time. Um, I guess one thing maybe we should add, we can probably add it later on when we're getting closer to redoing everything correctly. But we probably should have some sort of fuse, whether it's a PTC like a resettable or just a hard fuse. Especially something like a regulator, I would think that probably makes sense. Again, people, anyone who's used these evaluation boards or more evaluation boards than me, let me know what is kind of like norm. I don't use a ton of them. I typically will just get a custom board that will do spun up rather than using a evaluation board, but definitely let me know. And then no one else mentioned, is this fine? Power coming in from the left, our digital bus, whatever we want to call this, coming in from the left side, power out on the right side. I think it makes sense. So there's our input stuff, and then that will go straight to our Ferrite. Oh, what are our pin names? So we call these pin 1 and 2. 1 and 2, why are these not connected? Okay. I literally didn't do a single thing except pick up the ferrite on the schematic and put it right back down where it was. But I guess that's all it needed. Oh, crap. These should be on the output side of the ferrite, obviously. And another thing that I'm not as good at that I wish I was is keeping consistent grid sizes, like going down by 0.25 or 0.1 every time to keep everything aligned. I do my best when I do like the final cut after this, but that's something I've never been amazing at. Good to hear. I also hate making two-sided boards. I still make them myself. Yeah, I would say 50% of the time that we do a double-sided board, it's because we have to. We don't have space. The other times, I actually might have one. Hang on one second. Yeah, so 50% of the time it's because we have to. The other half is, so like this board has connectors on the top side, and then it plugs into like a bottom board here. So we couldn't have components. Oh, never mind, this is a single-sided. But anyway, a lot of times we'll have connectors, and we have to have parts primarily on the bottom side because of it. But yeah, that wasn't a great example. I forgot that that's only single-sided. Logic and input on the same side or logic on the long side. Okay, so we'll see. I was kind of thinking this might give us a lot of dead space here unless we can fit the regulator in on there. But we'll see, I guess, how it plays out on it. I think I'm gonna move the first cap right by the ferrite. Naming parts on two side. Sometimes I'll put footprints of bonus on the back side. Yeah. Oh, my green PCB was transparent, was it? So I finally found one that was. Oh yeah, go figure. Yeah, not terribly. On the sides it is. That's funny. Darcy, he means literally parts on both sides, not two-layer boards. Okay, so there's our not so important stuff. Now for the more important. So like I said in the last video and in the datasheet video, I think. Definitely the datasheet video. I will certainly look at the example layout that they have here. This one has a pretty in-depth one, but I won't take it as like mandatory. One thing I don't really like is they don't give you like a great full view of it. But I'll have this over on the other side. Makes it easier for me to do. And this is like the funkiest footprint that I've seen in a while. It took a while to do. Okay. Oh, T Electronics, you were talking about copper on both top and bottom. Well, that's technically called a two-layer board, and yes, 100% every board we'll ever do is at least two layers, two or four. I don't know what this will end up being. We'll see how the switcher ends up. But we can start trying to do it at a single layer. Okay, so pin 1 is our input side. There's our ground, so they want our input caps. Oh, that's a nice layout. It lets you put all of your inputs set up right here. That's a good start. That's a very good start. So then on the inputs, this is the 12. It's a really small part. I didn't think it was that small. That's impressive that this thing, even on the bigger one, can do 50, right? 40, 30, 40, 50 amps, something insane. That's crazy. One cool thing about this IC that I saw, so the internal FETs, the high side is 4 milliohms and the low side is 1.4 milliohms, which is really, really small, which is, I guess, why it can be so small of a part, but still crazy. It's almost midnight here. Check this later. All right, man. I appreciate you stopping by. Oh, and speaking of which, I haven't done my my plug for the stream. If you haven't already, check out a link in the description for the Discord. We're getting pretty close to 500 members, which is amazing. I never ever thought it would get to that point. And then also I have a link to a Patreon I set up. Any sort of support that you can do on there is much appreciated. Man, these are a lot of caps. Is GAN? I don't believe so. If it was, I assume they would have bragged a lot more about it than that. And normally this layout's going to seem quite excessive with just how many caps and everything there are. Keep in mind it's going to have to be rated for 15 amps in a buck, which is really, really high. So it looks excessive because it kind of is. But we'll see. What's the height of the IC? Will it take a heat sink with the caps close? I would, on something like this, if you really needed a heat sink, you're better off tying it in on the bottom side here. On the top side, you're going through the outer shell, or the case, which is never going to be great. But even if you were, I would much rather have the caps close and just live with it being hot. I wouldn't sacrifice the caps to have a heat sink on it. And one thing that we can definitely do on this layout is have, oh, I never did I guess I got lazy. I never did a proper paste mask and everything on here. So what we can have when I do the layout is thermal defined vias. So you can tie this straight to the bottom ground plane, which you can have massive. And that makes a huge difference for dissipating heat onto the ground. So there's our input ceramics. So the first thing you want to do with any sort of buck regulator, buck noise is on the input side. So your most important thing on a buck on the layout side is getting the input caps. That's first. Then after that, it's typically working on the inductor. We'll see. what the what our layout recommendation is. Oh, they're talking about the pores, but I do the pores after typically. Ceramic caps should be placed right between different values packages and hello Will. How are you doing? Then the V-in pin. So they want the V-in pin to take next precedence, which V-in is, wait, I'm already doing the V-in. What are you talking about? V-in pin 23. That's not what you call it, guys. Oh, V-in is different than PV-in. Got it. So where is pin 23? 18, pin 23. Got it. Okay. Good to know. So you make VDD on top and ground to the bottom. If it's a two-layer, sure. I'm assuming with all these data lines, we're probably not going to be able to get away with it being two layers, but we'll see. Okay. So that's one thing I didn't realize. I should have known there has to be a input supply for V in for the actual regulator, and they are obviously going to want, whoa, they're obviously going to want that to be decoupled. So what we will go ahead and do, oh, this is gonna get messy. What's the easiest way to do this? Let's get rid of this and lower it. Okay. So we'll put these caps here, and then we're going to want to have a, why is that showing two? Are there two on there? Okay. We're gonna want to have separate decoupling for this, and in that case, we're going to want to have a 603. So this part, but that's not in the current library. That's in my work library. So what we will do is change. Oh, it was. Okay, so this is supposed to be a 0603. So that means get rid of this. So we should have an 0603 up there. And now we will decouple the VN pin. And God, people fly down this road where the office is. Sometimes there'll be cops posted up, and it's like it's crazy. Like people will literally go like 100 down this road. And I know this obviously doesn't affect anything with the net because it's still connected here, but it just makes it more logical where the decoupling should go. The same reason why I put these over here, even though they're still all connected. I wonder what it says, how many they should have. Being necessary to put a decouple cap, so they just seem to say just one, so that's, I guess, all we'll do. Okay. U1 pad. Wonder why that error just now showed up. That's just because I merged all of these together when it really should have been like, what, 1, 2, 3, 4. But they're still going to connect the same, but I'll probably change that later on. Doesn't really matter for now. Okay, so this one we can put here. All right, so now V in is pin 23. So they want this to be decoupled. Yeah, and the fact that they don't have a ground here means we're probably going to have to do this 4 layers to give us a separate ground, but we'll see. What is pin 24? Pin 24 is PVCC, which that needs decoupling on it also. So let's see. Okay, so they essentially would rather have it like this, which if you guys were watching the last USB hub video, we kind of went through the same thing. When there's not a ground pin right next to it, you kind of have to make sacrifices on what gets precedence for the layout, whether it's the ground or if it's the power, which here there's just no room, so we really don't have a choice. Oh boy. The pad entry of KiCad still isn't great. And I know my grid isn't crazy small, but yeah, that helped a bit. The dragging is what they never fixed. There we go. 4 layers, not easy to make in the home shop. Yeah, I mean, while it might be like fun to do all that, in this day and age, it's not worth it. Cost and time wise, I mean, it's so cheap to get a board done overseas. And if you want to do anything in production, you're going to have to end up essentially redoing your layout to make it compatible with something in production. So it normally isn't worth it. At least in my eyes. Why is that a different size? Oh, I guess it's not. Yeah, track routing really needs fine grid. Yeah, the dragging is what drives me nuts. So here what we can do, and I know I said I usually will wait to do this until the end, but this probably won't have to be changed too much. We should have this one be at the center point to make every other run equally as short, rather than one being a little shorter than the other. Since these are for decoupling, we want them to be as short as possible. Realistically, probably should have gone to 0402s. I didn't realize that this was going to be this tight. And that might be something we do down the line. I'm not sure yet. But typically when a layout gets this tight, I'll switch over just because that would cut in this space like by half. Okay, and we're going to have to save room for VDD because that goes to one of our jumpers. But for now, that should be fine. Okay, so they want V in, then they want another plane. Oh, that's where they want the inductor. Okay. So they want... See, they really don't show an overall view of this at all. So this is the switching node, right? Yes. So while I said the input side is the most important thing to do first, This is the most important net in that it's the noisiest. So you need this singular net to never get near anything else on your board that's important. Or if you're doing like a mixed layout, never have anything, even digital, going on a layer below this, because it's just insanely noisy, because it's what's doing all the switching. Such a big inductor. It's funny because it's only 1 microhenry, but it's like a 20 amp inductor, so it's a beast. This actually might work pretty well, but yeah, we don't have a great option here with just how massive this is. If we could get this up a little bit, let's keep this down here for now and see how it plays out with these later on, because it might make more sense to bump this up a little bit, but we'll see. So you just reorder them if you want to change something in the layout. That is my concern before I test it. Oh my gosh, yes. So basically when we're doing a job for a client, like a paid job, in the proposal it says, and it depends on the complexity, but every single proposal I'll ever do, it essentially says, due to the nature of laying out boards, most designs require between 2 and 3 new revisions. So what I typically will do is, obviously we'll review and do the best we can on the first spin, but it's pretty much my assumption that every layout I will ever do is going to require at least one more revision, if not multiple. My goal with the first revision is to be able to test everything. I don't care if it works. I just want to be able to test everything so I know what doesn't work. It sucks when there's an issue that messes up testing something else, because then you could do the next revision and be like, oh crap, there was something else that wasn't working. So as long as I can test everything in the first revision, I'm super happy. Stack the input caps above. Like, why does it need to come in from the side where you got the 3 prongs top side? You're essentially talking about like this, I believe, which, yes, totally agree. And that's what I think we're going to do, at least with a couple of these. It's just not super important right now because I just want to get a rough layout for the start. Okay, so now that that's done, and most likely what they are going to say is the next most important thing is to route the sense pins, because you need to keep that away from the switching node. But that's pin 10, pin 11 and 12, which are right here. So the biggest thing not to do is, if you were to take this and go right here, like 99% likelihood that your board will not work, or at least it's going to work incredibly bad. So this vsense line is what checks read your voltage on the output. So if it crosses over this switching node, which is insanely noisy, probably one of the noisiest parts of any board you'll ever do on a buck converter, it's going to couple all that noise to here, and it's going to be absolute garbage. So I'll see what they say. I am thinking we would take it down and around here. Because if you go here, then you're on the input side, which, while much less noisy than the switching node, it's definitely going to be quieter. But let's see what they say. Oh, they want the bootstrap cap next, which makes sense. And this is just for the driving of the high side MOSFET. Yeah, I gotta say this IC, they're making the layout quite easy. It's nice when they do that. You kind of would expect it being a really modern IC. Some of the older ones, when they didn't know as much about good layouts, that's when they usually stink. What is pin 5? That scares me. Oh, that's the test point. But what a terrible place. Why would they not put that on the other side? That's the low side or high side gate debug pin. I don't know why they wouldn't put it on the other side, because they know that you're going to have traces right here. So they know you're going to have to drop it down to the next layer, but that's kind of nitpicky. Okay, so we have our bootstrap caps. Oh, and they do say to use 0402s for this. So yeah, we'll probably swap to 0402s for all of our signal parts. Yeah, and look, so signal routing, they do want it to go in the exact same way that I was thinking. Why do they show R sense? They have a resistor for R sense. That's not what they said. Yeah, and they don't even show it on the block diagram. I mean, it makes sense. It helps reduce some of the noise, but then you would also want to have a cap going to ground, which they don't have. So they have an R sense. I can't tell what that is below it. Wonder if I can delete that. Huh, that was pretty good. So they have an R sense, two R senses. So that's for ground, and then on the positive side, I believe. Um, yes. So I don't know. I don't know why exactly that they are putting on their layout. Um, whoops. A resistor there. I don't know. It doesn't show in any of the simulation or in the data sheet. I guess we just won't do it, but who knows? I mean, I certainly can understand why they would want it, but it just, again, sucks that data sheets have to do stuff like that. Good thing they included the schematics. I know. Yeah, and I looked on their website too to see if they had anything else, and they don't have squad. They have a app note for improving jitter and remote sensing, but that's it. That's one of the disadvantages of a new part, is they don't have near as much documentation ready. So then the R sense could be to balance the thermal junction when soldering the part. Um, I mean, if you're reflow, I don't know exactly what you're referring to, but if you're reflowing this, it's not going to do a whole lot. I mean, everything here is going to be up to temperature. Do they have a forum? They have like a technical thing you can ask, but I normally don't do that. It usually isn't worth it. I never get a response. So they put dummy resistors just for the thermal junction resistance to be the same on two pins. Um, I guess. I guess I can buy that. Do they? They don't mention that in the data sheet, do they? No. That would be too easy if they told us for sure. Pin 16 is considered analog ground, which should have a single connection to power ground, the A ground. Okay, so we're having both of them tied. VSEN plus and VSEN minus differential analog signal pair should lay out using minimum clearance. So it's a differential pair. Also, the differential pair should be far away from the voltage switch node, of course, and other signals throughout the length. So they want this to be a true differential pair going to the ground side, but that's the internal comparator will have an offset because of this when the IC heats up. No, I totally see where you're coming from. It's just frustrating that they wouldn't say it. Forums are hit or miss, but I've been impressed with TI. Yeah, I've seen TIs being pretty decent. Will you change the trace width later? Oh yeah. Um, like I always say, I just do rough layouts at the start because I know I'm going to have to go back and change a bunch of stuff. So instead of wasting my time now, I do it as quick as possible to get the overall layout close, and then I will fix it later. So since they want these to be true, like differential pairs essentially, we'll do a copper keep out to keep this from just blending in with the rest of the copper. But they don't really, so probably uses a circuit from that app note that does it. That app note shows the series resistors. If that's the case, yeah, we'll certainly come back to that. It's not super important right now. Adding thermal vias, obviously. Ground layer. Okay. So that is pretty much all the recommendations. What's funny is they say to keep all other signal traces away from here. Yet here we are having to go straight under these. So yes, we're definitely going to need a 4-layer board. Okay, so what they do, and I think this makes a lot of sense, is we're going to want to have resistors on our signal lines here to help keep any, to slow the rise times and get rid of any noise that comes. Yeah, this is kind of a shame that they should have put these sense lines on the bottom so then it didn't have to cross any of these data lines, because the problem is this goes to the outside world and all of these lines are going to have to cross over our sensitive analog pins, which for obvious reasons isn't ideal. So what that really isn't ideal. So I still like this IC in the configuration, but that's a bit of a miss. And that's probably a reason why on all of the other pins they have series resistors, or I guess for the PG and VSET, the VSET you would have to. Um, but yeah, that's kind of a bummer. It's just one of those things. It's like they could have made it a lot better and a lot easier. So what I want to do now is let's move this out a way so we have more space. And we can start filling in. But yeah, this is definitely going to have to be a 4-layer board. And we'll do copper, core, copper. How do we change? I'm still getting used to the nightly. And then I hate how it always does that. It puts all the layers back. Does it help to alternate the different grounds between the VDDs to help with EMC? I don't really know what you're referring to. Does it help to alternate the different grounds between the VDDs? So all of this is um here. This is what I was looking for. So they still have that. Um all of this is just a single ground tied together. I don't have a analog ground. I've mentioned it before. More often than not, you're better off, even if they suggest otherwise, to just keeping a single ground. It doesn't make sense most of the time. Courtyard. Okay. So completely forgot what I was gonna say. Oh yeah, so we're gonna do signal on top, signal on bottom, and ground reference on the inner two. So what we'll do is just put a rough board outline just to start filling in the grounds to make it look a little prettier. Oh, was that? Whoops. Same color. Whoop. Edge cuts. So nice that you can put ground on multiple pores now. That's something that they have desperately needed. And I will have it filled on the top and bottom, but for now, we don't have to worry about it. And then for now, we'll do solid just because it looks cleaner. And do 0.25, and we can do a clearance of 0.25. I thought use digital and analog ground separately. No, not for this layout. It's kind of like what I always say, people who um decide to use deciding between a 2 and a 4-layer board. It is way harder to do a good 2-layer board than it is a good 4-layer board, because as long as you keep your ground returns just nothing on them, you're eliminating like literally like 80% of all EMC failures just by doing that. Same with analog and digital grounds. If you just tie them all together and keep the signals far apart, you're usually better off than most people who get all intricate with it. What's your clearance clearance? Right now I think it's 0.25 for everything. Something like that. Like I said, I don't really pay a ton of attention. Oh, until we're doing the final route. And these will likely all be pores, just because the high current will kind of make it to where we almost need to. But for now, that takes up way too much time. And I like not putting the copper pore on the top layer at the start, because then it lets you see where all of the grounds are connected without them just connecting on that top layer, which is super helpful as like a double check. Okay. So the layers are to separate some of the signal lines, not to introduce crosstalk. Yes, that is one reason. The other reason that it's really good to have signal, ground, signal, or signal, ground, ground, signal is it's really, really nice not having to worry about having a adjacent reference plane for every signal layer. So by doing it like this, every one of your signals is adjacent to a ground return, which is one of the main goals with any stack up. Okay, that's most of the grounds. So now, whoa, got completely zoomed out. Because what's so weird is normally on like the S alert pin, that's an interrupt from this side out. Normally you would put the resistor here to slow down the rise time to help not introduce any noise here. But the fact that we more are going to care about noise being introduced from the outside, the cable out here, we're probably going to want that resistor to be on this side, which is kind of odd. But for now, I think let's just run everything out and we can worry about that later. Why some stitch vias were placed under the component? That is the better way. I shouldn't have done them the other way. That made no sense, I know. Give me a second. Let me finish this. I'll go back to it. I literally just missed. Okay, so ideally, so since we're going to have a pour here coming in, so all this is going to be power. The goal with any ceramic capacitor is to lower the loop inductance. So if we had this, and when I said I shouldn't have done these, they should always be on the inside. So if this is its only connection to the ground pour, your loop from grabbing any power from the capacitor is going to be on this side, where if it's in here, you can grab it like this. And another potentially better example is, let's say we had our power coming in on an inner pour. Now the loop area is even closer on this side. So the closer you can get your input vias to each other is always going to be better. On like 1210 caps, it's not as big of a deal because the loop area is already pretty massive, but you still do the best you can. So that's the RT sync pin. Yeah, we're gonna need to have 0402s pronto. So let's do that, I guess. Let's change all these. Edit symbol fields. So that one has to be an 0603 because it's a 4.7. Our 1U, that can be an 0402. That's, what is that? That's our 2.2. That has to be unless we change the value, so we'll keep it like that for now. That can be changed, and then all of our resistors can be changed. Thanks for the clarification. That's what I thought. No problemo. Okay, and now let's replace footprints. So this doesn't have an update footprints, which is... Oh, it did. Okay, it does. Good. So yeah, this is going to be really nice now, having these be a lot smaller. 0402s in most of our designs lately, in the last couple years, that's pretty much what we'll use if we're even remotely trying to deal with size, or if there's anything high speed. They're plenty easy to place. We won't use anything really smaller than that typically, or not typically, never have. 0201s get to where it's hard to hand place and very hard even on a pick and place. Because our pick and place is spec to 0201s, which if it's spec to that, that essentially means you never want to run it at that. You always want to be a little bit in like the safe zone. Any BOM optimization regarding footprint and value? So this is not the way I do layouts at all. When I'm doing a layout for work, I have a library that we use. So like if I want a 2.2 mic that's 0603, I have one saved, or like a 0.1 mic 0402. I've got some here. So now these are fully linked to ID. It should have a manufacturer's field, data sheet, footprint, all that. So the BOM is essentially generated on the fly. But for this, since I'm not going to be sharing our library, I'm just doing it like, I guess, the standard KiCad way. Man, these headphones are killing me. I guess no more music for today. It's so funny how that happens. How you wear headphones for a while and they like hurt your ear. Okay. So now what is 15? So 15 is V set, which is our voltage set pin, which we need this. So these we're obviously going to have to run farther out. So what I'm going to do is just keep them just stubs for now, but I'm thinking we should also move these down, or this trace down, because having better room for these is going to be more important. And what is 14? 14 is address. And then just P good. Yeah, that really would have been nice. Or you know what they should have done? They should have put the vSense right here. That would have been the best case scenario. It's still far enough away from this, unless what it is they wanted to keep on the silicone. This is probably it. They wanted to keep all the analog on this side, and 16 is technically what they said is the analog ground. So I think they probably kept it over here to have more separation, which is fine. But if this is the analog ground, they easily could have put the two analog pins right next to it. But anyway. Okay, so P good. We'll just go out to the connector. And now we can move S alert. And since now it's a four layer board, we don't really have to care about trying to keep lines on the top layer. So once we drop a via down for saving a via, if it's going to an output connector, we'll just keep it. There's no purpose not to, or no reason not to. Okay, now we can add these traces. Oh, and a question, since, because I've asked stuff like this to people on the Discord, but that's a mixture of people who watch videos and some who do live streams. For the people here who are watching the live streams, what do you guys prefer? Do you prefer the live streams or the actual like standard videos, or is it like a mixture of both? Like if there's a live stream on, you'll watch it, and if a new video comes out, you'll watch it, or vice versa. Let me know, because I personally really like doing the live streams. Ugh. Okay, these will move out a little bit. The only one that really matters being close is the RT sync pin, which is the bottom. So maybe we'll move these out a little and then try to keep the sync a little bit closer. Mix is good, both. All right, that's what I figured. What's nice about the live streams is no editing. And then ground. I knew it was going to do that. Mix is good. Live stream is fun. That'll work. Videos for well-defined stuff, live streams for how I do it. Yeah, that's kind of what I assumed. At least that's what makes sense on my end. Okay, so there are caps. So Ahid, you never I don't think you answered. Did the app note that showed it using these resistors, but that was for a different part, right? Same ground under part? Yes, same ground. This is the analog, so we can tie it. Oh, that's lovely. The joys of having a really weird footprint. There you go. Video is good for tutorial style, but seeing someone do things is more my way. Yeah, that makes sense. I appreciate it. Appreciate the feedback. What is pin 7? Pin 7 is... Pin 7's an analog ground. They said that pin 16 was. There's two analog grounds. Oh, yeah, the hotkeys. Was that you who suggested it? Someone suggested that in the Discord. I can totally... I completely forgot to try that. Well, here, if anyone, it was to a GitHub. If anyone wants to leak that, yeah, I can certainly try that. Keystrokes could be helpful. The app note says to use resistors with caps to reduce jittering. I don't use KiCad, so hotkeys are not interesting. Okay. What is pin 23? Why is that all the way over there? Oh, that's power in. Okay. Wait. That's gonna be a pain. Um, I mean, I guess maybe not. We'll just do something like this. What's the setting to make the program indicate track clearance violations? Oh, you have to go to your interactive router settings and do shove or walk around. Walk around doesn't work great for me. Shove works pretty well, and it'll highlight them. From the viewpoint of noise and jitter analysis, voltage signal at two remote sensing pins indicate not only load's terminating voltage VO, but also external interference picked up. That's from the app note. Yeah, I mean that makes sense. I just wish they would have said it. I just wish they would have said that in the data sheet. It's almost like I just made a video on how to read data sheets. At least I did mention that no matter how many data sheets you read, they still kind of suck. But I must say this one's been pretty good. I'm pretty pleased with it so far. Okay, ground to ground. Ground's over here. Since they're using these as diff pairs, we'll tie those to ground here. So I guess, did it say a value of resistor for the sense pins? Not that it matters. We'll just throw on a 10K so we can have the footprint. It is weird taking my headphones off though because my microphone has a I use my headphones from my microphone and it plays back my voice so I can hear like how loud it is and whatnot, and it's funny like now just hearing it outside it sounds so weird. Before it's like I'm almost talking to someone. Okay, annotate. All right. App note says 51 ohms. Got it. Hope that's not a mosquito. The joys of living in Oh, wait, let's be good. We don't care about. We'll throw that on the bottom layer. Joy of living in Florida, mosquitoes everywhere. Oh boy. Oh boy. They also have a 1 mic cap between the sense pins and the load lines. Yeah, that's what when we originally saw it, that was the first thing that I had said is if you're going to have a RC filter, which makes sense, where's the C? So yeah, that makes total sense that they would want that there. It is just weird. It's like I see the advantages of this sort of configuration compared to the standard voltage divider setup, but I guess it's a bit more of a pain to lay it out. Yeah, I'm assuming the caps will just throw right in here. Okay, so those are good. What is 17? 17 is RT sync, so S alert goes out, SDA and SCL. So presumably our finished layout's going to be something like this. What do we want to do? Whoops. What do we want to do now? Connectors and jumpers. If we put it like this, we can have our jumpers right here. Or I guess, yeah, we essentially keep it like it is. We can have all of our jumpers here, and then our power output, whoops, our power output will be right here. Or we could, I guess, have the jumpers down here. Space-wise, I think this makes the most sense. Let me know if anyone sees an issue with that. I don't think there is. But in the meantime, what I'm going to do is, and we can just use 220s, is I want to have for all of these, or at least for the ones that are going to go by the V-Sense, I want to have a series resistor to help with noise. Oh boy. And I know I had just said it was weird to me that they didn't have a RC before I realized they did, and now I'm just putting an R. It's true, but since this is from the outside world, more so what we're kind of worried about is like noise from like ESD or some sort of garbage from outside, which Series R will work for pretty well. But yes, if we could put a capacitor on these lines also, that would be amazing. But I squared C is pretty tightly limited on what the maximum bus capacitance is. Don't remember off the top of my head. It's like 470 picofarad, something. But that's actually kind of bit me before I'd forgotten about that and tried to do it to filter it. But it's not an RC filter to ground, that's the thing. Where's it tied to? Between the sense pins and the load lines. Okay. Well, it is to ground because the differential pair is technically to ground, unless, again, I haven't pulled up the app notes, so I don't really know what it all says. But if it's between the diff pairs, then yeah, I mean, it technically still is to ground. It seems to be a feed forward to capacitor. Yeah, but if it's a feed forward, that would essentially be injecting some ripple in there, which is funny because they're quite adamant that you don't have to. Where's the data sheet? Because here's the differential amp, because it goes into a comparator, ramp generation gets compared with that, which then changes the duty cycles here. Yeah, I mean, I wouldn't see where doing it this way would need ripple unless comparing it on this side. I'm not sure. Select wires and press tab to drag instead of broken then connecting. Yeah, that's probably one of the things that I need to figure out with the new KiCad. I mean, maybe it was there in the old one. Okay, so there's our resistor. So these we will throw on the connector side. I guess the one thing that I would appreciate is a little more explanation with the sensing on here. I mean, yeah, they show the block diagram, but it's kind of fairly abstracted. And it's like if you're doing something that's this like different than everything else, you probably should give us an idea of like how exactly you're going about doing it, but that's just me. Caps are in parallel with the resistors. The caps are in parallel with the resistors? Got me. I don't know why. That doesn't make sense to me. Don't you put diodes after the input resistor? Yeah, you could totally do TVS diodes. And if this was a board, like production wise, that I was, yeah, I mean, we could. But yes, normally on a board like that, I would be selling, or for a client, yes, that would absolutely be what we would do. Anything that leaves the board should have them. I just never really thought to put them on here. And we're not going to have room here, are we? Nope. But series resistors are amazing. They can solve so many issues with EMC and signal integrity. So even if you do have TVS diodes, it's still a fantastic idea to have series resistors. Pretty much if you can get away with it and it's not like something driving a load, you virtually always want to have it. P good. What is the setup for P good? So that's just a pull up. So P good goes here. Maybe we put the jumper at an offset angle. Do it like that. Maybe that makes sense. Okay, so external voltage comes in here. And that gives us basically our series are most microcontroller problems, EMC issues are a reason people don't know. Yeah, a lot of that stuff ends up being fairly cryptic, unfortunately, but is what it is, I guess. Which that's why, again, not to be repetitive, I'm super excited to get that EMC series going because I think it'll be quite useful to people. I'm so confused with how we did this jumper setup. I don't know where any of this is going. Pull up voltage. Pull up voltage goes. Oh, these go to the I squared C lines. Yes, that's right. So maybe we just do like this. Okay. Oops, wrong way. And yes, I know that this is like a complete cluster over here. I will 100% be adjusting this. I just want to get it roughly laid out first. It makes it a lot easier to see where everything should go. Though, actually, maybe. Why drag P good down again? Just continue from the bottom. Good call. But yeah, I probably am gonna redo some of this. This is really ugly. We can move P good up here to get this more in a line. Okay, P good's there. Now we can probably do the same. No, I want to keep our resistors there because if we are expecting some sort of noise, we might as well keep those closer. Okay, so now these pull up voltage. Yes, because we need more people like you, because it's your long experience that textbooks always don't cover. That's the goal. That's the goal, at least. But there are some really good books out there. I mean, that's essentially where I have learned what hasn't been real world has been from books or lectures, conferences, stuff like that. Whoa. Okay, now, yeah, this is a good bit cleaner. But now we are getting back to being close to these, which I don't really want. And they are kind of noisy signals because they're I squared C. Well, I liked your idea at the time, Ahid. Now we change it. Because now we can bring these down below. Flip order of P good. All right, you win again. Yeah, I mean, that does exactly what I was going to do, but it does save a via. If you swap P good with external, would that be better? I don't think we have to. I think this works. We'll see though. Yes, that will do. And now, if we swap these two, we don't even have to go on the bottom layer. Don't you love it? The most painful part of this layout has been pull up resistors for an I squared C bus. Okay, from what I've read, the filter on the V sense pin, if the load is really far from the regulator and you are sensing the voltage at the load, the long tracks will pick up more noise. Yes, that certainly makes sense. It's still, I would expect that to be something that should still be mentioned in the data sheet, at least in brief. But yeah, I mean that. Oh, come on. That's another thing KiCad never got figured out is when you drag something like that. Will you do stability test at the end to show your buck will work under changing loads? Sure. Yeah, that sounds like a good plan. Try to place top I squared C resistors on top of bottom I squared C. That makes absolutely no sense. Sorry, I'm not following. Okay, that's good enough for me. Not amazing, but it's good for now. Okay, so 2.5 volt output. Now we have our resistor and LED. And then obviously we'll be changing our pins, our output connector, because it'll have to, obviously, a 2.54 millimeter pin header will not source 15 amps. It could try. This is, what is this for? Oh, enable to keep it always on or not. Does anyone remember what this jumper is for? Oh, if we wanted to turn it off, right. Yes, that makes sense. For testing purposes. Okay, what is this? Because we're not going to be able to get an enable. That's VDD, which naturally we would like to be close, but we're not really going to have a choice here. So each pin vSense or filtered IC's output, yeah, makes sense. Also allows you to connect micro to enable. Yeah, but there's already. Oh, we don't have an enable out here. Oh, well, you guys didn't ask that you wanted it, so I think it's fine. But yes, that would give you the ability to do it there. Okay, we're gonna have to move this. What a pain. Isn't it enabled via I squared C? Yes. And that's why we didn't do that, because with I squared C, you can adjust all of that on the fly if you want. Once again, you meet your. I know, right? It's been messing me up this entire time. Okay, there we go. That works. What is the purpose of the enable pin? I always leave the IC running. A couple people had mentioned last time that for this it could be kind of useful. So say if you're just trying to mess with the programming and you have this connected to a whole system, but you don't want to power the system and you just want to test it, you could just bypass the enable on here and then you don't have to worry about it. But that's the only, I agree with you. It's not overly useful. But I can see it in that specific case that it could be useful enough at least. Oh, and then we need VDD. Dang it. I'm gonna have to move this again. So yeah, we're not gonna have a choice but to move this down then. Okay, that wasn't too bad. And VDD, we can cut across here. I still normally don't like bringing bottom layers across, but 4 layers, it should be fine. And then test points, which still this one makes no sense to me. why they put it in between here. Okay. There's that test point. We can connect our power. Is there a special reason why you keep the pad output wire always straight? So I would like to say there's some amazing reason for it, but pad entry is mostly because it looks good. Back in the day, there would be a big issue with it, and uh, acid traps, but that really hasn't been an issue for since before my time of doing layout. So it's just one of those things that's kind of still done as a standard, but no, there's really no reason. And this is our other. Oh, geez, that's actually hard to connect. I guess that works. We're gonna have to see how important that test point is because we're gonna want to make this a bigger pour, and that probably will interfere with it, but we'll see. Tombstoning can be, that is not a cause of tombstoning that I have ever heard. Um, Unbalanced copper, sure, that's probably the biggest reason, but just because of the pad entry, I am not sure about that. Um, the biggest cause of tombstoning that isn't caused by like assembly, like if you have it too fast of a ramp up and not enough soak, that can do it. But from a standpoint of design, the biggest cause of that would be if you did something like this. Why is it not letting me change trace width? Hello? There. That was weird. So if you did something like this, or even worse, if this was connected to a pour and you don't have thermals, this will heat up slower than this. So this side will lift off the pad and you'll get a tombstone on this one. That's the most common design related reason. Ground we can just tie there, I guess. Asymmetric. Test point on bottom layer. Yeah, I mean, that doesn't really matter to me. Either or works. Okay, 5-volt output. I think that's pretty clean. Like that. And like that. And here. And look at that. First cut of this is done right on time. Let's see what we get, DRC. Oh, boy. Oh, I used all of these are 0.25 instead of the 0.3. Outstanding. But I could have sworn I made the minimum 0.25. Oh, I never went back and changed this. I hate how they changed the look of it. Drill out of range. Okay, I guess I didn't change that too. Think that's it? There we go. I don't know what all these warnings are for. Oh, it's probably for courtyard issue. Off to PCB way and see all of these traces burn up with a big load. That would be a fun video. How much current we can go through without them burning up. Oh, silkscreen clipped by solder mask. That's a thing that it does, and silkscreen overlap. Go figure. I love this design rule check. It's amazing. Via not connected or connected onto one layer. That is such a good feature in the new KiCad. Because like that via was doing absolutely nothing. So it's so useful that it points it out. So what? Oh, it's complaining that the silk screen is clipped, right? So if I do this, then it'll stop complaining on that one, right? No? Oh, yes. Okay, cool. Okay, sweet. So that's actually here. Always look at the 3D viewer first. Sweet. So yeah, that's where I'm gonna leave this video. I will, as always, I'll push this to GitHub right now so you guys can take a look at it. I guess probably do one more stream on this next weekend, finishing up the design, beefing up the traces, making any other changes. Then I'll go ahead and get this ordered, and then the entire video summarizing the design and the layout will be on a separate video, and that will be where I go through and test it and like stress test it and everything, and hopefully first revision works, and then potentially sell this board if people want to buy it. I'm not exactly sure yet, but we'll see. And then after that, probably back to the USB hub on stream. But anyway, I appreciate you guys for watching. Once again, link in the description to join the Discord and the link to my Patreon. Any support you can provide is fantastic. And I will catch you guys in the next stream. Have a good one, everybody.